In this question, you have to find sum of odd integers from 1 to 201. That means 1 and 201 are included in our interval. So, first of all, let's get those terms. Now, the odd integers are starting from 1, then 3, 5, up to 2001 because it is also an odd integer, and it is observable that our sequence are in AP. Our next step is to get basic terms of AP. Here, your first term is 1. Then the common difference between second term and first term is 2. And the last term of AP is 2001, which is also your T of n, which will be helpful in your next step to get total number of terms. So, your Tn is actually a plus n minus 1b. Now, let's substitute the value. Your Tn is 2001, then a is 1, and the common difference of AP is 2. So, 2001 minus 1 is equal to n minus 1 into 2. And if we move this 2 on the left hand side, we'll go it in the denominator. So, we'll get n minus 1 is equal to 1000, or we can say your n must be 1001. So, we get our unknown term, and we are ready to find summation of n terms using second formula, where number of terms is 1001, then your first term is 1 and last term is 2001. So 101 by 2 will be as it is. 1 plus 2001 is actually 2002. So here we'll get 1001, and your final answer will be 1002001. Ta-da! Now let's move to the next question. In this question, we have to find sum of all natural numbers lying between 100 and 1000, which are multiplier of 5. That means your 100 and 1000 excluded. You have to find in between numbers which are multiplier of 5. 105, then 110, up to 995. So, we can say our sequence is in AP, which have the first term is equal to 105, and the common difference between second term and first term is 5, and the last term of the sequence is 995. Now, in our next term, we have to find number of terms, which is also equal to Tn, which will be helpful in our next step to find total number of terms. Your Tn is actually a plus n minus 1d, where your Tn is 995 and first term is 105, your n is unknown, and the common difference is 5. So, if we move 105 on the left hand side, we will get 995 minus 105 is equal to n minus 1 into 5, and to make n subjective, we have to move 5 on the left hand side, will go in denominator. So, we will get n minus 1 is equal to 178, or we can say number of terms are 179. So, we are ready to find Sn using second formula, where total number of terms are 179, then first term is 105 plus last term is 995. So we'll get 179 by 2 into 1100 will give us Sn is equal to 98450. Ta-da! Here the question is, in an AP, the first term is 2 and the sum of first 5 terms is 1/4 of next 5 terms, and we have to show that 20th term is minus 112. So let's consider one AP of 10 terms. Now it is given that your first term is 2. That means A is equal to 2. Now to use your second condition, we have to find sum of first 5 terms, and we know that sum of first 5 terms is given by S5 and sum of next 5 terms, that means from A6 to A10. So to obtain this summation, we have to consider sum of 10 terms. So we can say sum of first to 10 terms is actually S10 minus S5, and it is given that sum of first 5 terms is 1/4 of next 5 terms. So to get the unknown, which is common difference in our AP, let's use this condition, and we know that sum of first 5 terms is S5 and sum of next 5 terms is S10 minus S5, which is actually 1/4. Now let's simplify. This 4 will move to the left side, we'll get 4s, then this minus S5 will move to the left side, we'll get 5 times S5 is equal to S10. Now let's use the formula of summation of n terms. So we'll get 5 by 2, 2 times A plus 5 minus 1, or we can say 4D is equal to 10 by 2 10 by 2, 2 times A plus 10 minus 1, or we can say 9D. Now let's simplify. This 2 will cancel out. We'll get 5 2s are 10, and open the bracket. 5 into 2A will be 10A, and 5 into 4D will be 20D. And on right hand side, 2 into 2A will be 4A, and 2 into 9D will be 18D, which will give us D is equal to minus 3A. But and we know that your A is given by 2. So we can say the common difference in our AP is minus 6. if you remember the question, we have to prove that your 20th term is 110 minus 112. So, using formula of nth term, let's see. We can say T20 is A plus 20 minus 1, or we can say 19D, and we have value of A and value of D, which is minus 6. So we will get minus 112, which is your 20th term. Hence proved. Ta-da! In this video, we are going to see solve some basic problem based on the arithmetical progress, and see and try to understand the fundamental terms like understand the fundamental terms like first term of the AP, common difference, last term, and also going to see the basic formulas like nth term and different formulas of summation of n terms, and different formula of summation of the n terms. Now let's see the question. In this question, we have one AP having terms as minus 6, minus 11 by 2, minus 5, and so on. Now, first collect the fundamental terms like first term, which is minus 6. Then try to find common difference between second term and first term. So it will be 1 by 2. Now, you have to find how many terms are needed to give the sum minus 25. That means you have to find number of terms for which your Sn will be minus 25. So, in this question, we have only one unknown, and depending on the data, we should use formula of summation of n. Now, let's substitute the values. Your summation is given by minus 25. Number of terms you have to find out 2 times your first term, which is minus 6 plus n minus 1 into the common difference, which is 1 by 2. Now for simplification on the right hand side, let's take LCM of 2 and we will get minus 24 plus n minus 1 divided by 2, and rest of the terms will be as it is. Now this 2 2s are 4 should be moved on the left side, so we'll get minus 100 is equal to n into n minus 25. So it will become n n's are n square, and n into minus 25 will be minus 25n, and just move this minus 100 on the right hand side, we'll get plus 100. So we get a quadratic equation will be factorized into n minus 5 into n minus 20 is equal to 0, which will give us n equal to 5 or n is equal to 20. Therefore, the required terms is 5 or 20. Ta-da! Now let's move to the next question. In this question, we have one AP having terms like 25, 22, 19 and so on. And from AP, we can collect fundamental terms like the first term is 25 and common difference between second term and first term is minus 3. Now, it is given that sum of certain terms is 116. That means your n is unknown to us and it is given that Sn is equal to 116 and we have to find your last term. That means we have to find An, and for that we are going to use the first formula of Sn. Now let's substitute the values. Your Sn is 116 and your n is unknown. Then 2 times first term is 25 plus n minus 1 into your common difference, which is minus 3. In further simplification, 2 should be moved on the left side, will give us 232 is equal to n into 2 times 25, or we can say 50. Then minus 3 into n will give us minus 3n, and minus 3 into minus 1 will give us plus 3. So 50 plus 3 will be 53 and minus 3n square is equal to 232, or we can say we will get 3n square minus 53n plus 232 is equal to 0. So we get a quadratic equation which can be factorized as 3n minus 29 and n minus 8 is equal to 0, which will give us n equal to 29 by 3, which is not an integer number. So this option is not possible, and n equal to 8 is a acceptable answer. So we can say the required last term is T8. So it will be a plus 8 minus 1 into d, where your a is 25 plus 7 times d is minus 3, or we can say 25 minus 21 will give us T8 is equal to 4. Ta-da! Here we have one question of AP, and it is given that the pth term is 1 upon q. That means Tp is equal to 1 upon q and qth term is 1 upon p. So Pq will be 1 upon p, and we have to prove that sum of first PQ terms is PQ plus 1 by 2. So let's convert our first condition into the equation using formula of Tn. So for Tp we have to replace n by p, and we'll get a plus p minus 1d is equal to 1 upon q, and for Tp we have to replace n by q. So we'll get a plus q minus 1 into d is equal to 1 upon p. So we have two equations and we have to obtain a and d. So let's try to solve them. Let's take a difference between equation number 1 and 2. Your a will be cancelled out and we can take b common. We will get p minus q, and minus 1 minus will cancel out, and on right hand side we'll get 1 upon q minus 1 upon p. So if we take LCM, we will get p minus q upon pq, and your left hand side will be as it is. So here p minus q will cancel out. We will get d is equal to 1 upon pq. Now substitute
the value of d in any one equation. Let's substitute in equation number 1. So let's get your equation number 1, and instead of d, let's place 1 upon pq. Now, for simplification, let's multiply 1 upon pq with p, so we'll get 1 upon q minus 1 upon pq multiplied with 1 will give us 1 upon pq is equal to 1 upon q. Here, your 1 upon q will cancel out, and we will get your first term is equal to 1 upon pq. So, we get our first term and common difference. Now, to get summation of first pq terms, let's use the formula of Sn. So, for first pq terms, we have to replace your n by pq. So, we'll get pq by 2 into 2 times a, which we find as 1 upon pq plus pq minus 1 into common difference, which is also 1 upon pq. Now let's simplify. pq by 2 will be as it is. Here we have 2 times pq, then 1 upon pq into pq will be 1, and multiply with the minus 1 will give us minus 1 upon pq. So 2 pq minus 1 pq will be 1 pq. Rest of the terms will be as it is. For further simplification, let's take an LCM of pq. We'll get pq by 2, 1 plus pq upon pq. So this terms will be cancelled out, and we will get as pq is equal to pq plus 1 by 2. Hence proved. Ta-da! Here we have sum of p terms of AP is equal to sum of first q terms. Then we have to find sum of first p plus q terms. Let's consider an AP having first term is equal to a, which is not given, and the common difference is equal to d, which is also not given. So we have two unknowns. Then the first condition, which is given in the question, sum of first p terms is equal to sum of first q terms. So on left hand side, we have to replace n by p. So get p by 2 into 2 times a plus p minus 1 into d. And on right hand side, we get q by 2 into 2a plus q minus 1 into d. So here 2 will cancel out, and let's open the bracket. P multiplied with 2a will give us 2ap plus p multiplied with the second term will give us p square d minus pd is equal to same type of term will be get on the right hand side. Now let's take all the terms on the left side and collect the same terms. From first term we can take 2a common, so get p minus q. Then from the second terms we can take d common, so get p square minus q square, which can be factorized into p minus q and p plus q. And from the last terms we can take minus d common, and we will get p minus q is equal to 0. So in all terms we have common factor p minus q. So remaining terms will be 2a plus d into p plus q minus d is equal to 0. So here we'll get 2a plus d into p plus q minus 1 is equal to 0. Let's say this is our equation number 1. Now let's remember what we have to find. We have to find sum of first p plus q terms. That means you have to replace your n by p plus q. So you get p plus q by 2 into 2 times a plus d into p plus q minus 1. But we already calculate in equation number 1 that this bracket is equal to 0. Therefore, sum of first p plus q terms will be 0. Ta-da!
In this question, we have to find sum of n terms of AP whose kth term is given as 5k plus 1. So, here we are going to learn using nth term. We can obtain summation of the n terms. Now, to obtain any formula of AP, we need first term and common difference. So, let's obtain your first term by taking n is equal to 1. So, you will get t1 is equal to 5 times 1 plus 1, or we can say 6 will be your first term. Similarly, to obtain common difference, we need second term. To obtain second term, we have to take n is equal to 2. So, we'll get t2 is equal to 5 into 2 plus 1. So, we'll get 11 as a second term, which will be helpful to obtain common difference, which is difference between second term and first term. 11 minus 6, or we can say your common difference will be 5. So, we get first term and the common difference, and we are ready to obtain the formula of summation of n terms, which is nothing but n by 2 into 2 times a plus n minus 1 into d. Now, we just have to substitute the value of first term, which is 6, and the value of common difference, which we obtained as 5. So, we will get n by 2 into 12 plus 5n minus 5, or we can say n by 2 into 5n plus 7 is your required equation. Now here, I will suggest you one shortcut method to obtain common difference from the equation of nth term, in this case which is 5n plus 1. You can directly get the value of common difference by coefficient of n. Ta-da! Use this information smartly. In this question, it is given that sum of n terms is equal to pn plus qn square, where p and q are the constants and we have to find common difference. And you know that to get common difference, we need second term and first term. So first of all, let's obtain your first term by taking n is equal to 1. So we will get summation of one term, which is your first term, will be equal to p into 1 plus q into 1 square. So we will get first term is equal to p plus q. Now, if we take n is equal to 2, then we will get s2, which is summation of first and second term. So we will get p into 2 plus q into 2 square. So we will get a1 plus a2 is equal to 2 times p plus 4 times q. But we already find out the value of a. So we can get the value of a2 by moving the value of a on the left side, and it will become minus. So we will get a2 is equal to 2p minus p, or we can say p, and 4q minus q will be 3q. So we are ready to get the value of common difference, which is second term minus first term, where your second term is p plus 3q and a is p plus q. So we will get common difference is equal to p minus p will be 0 and 3q minus q will be 2q as your final answer. Now it's time for shortcut. You can obtain common difference from equation of summation of n by simply double the coefficient of n square, and you will get your answer. Ta-da! In this question, we have ratio of sum of n terms and we have to obtain ratio of nth term. So, first of all, you have to consider two arithmetical progressive series in which the first term are small a and capital A respectively and common difference are small d and capital D respectively, and it is given that sum of n terms of this 2AP is in the ratio of 5n plus 4, 9n plus 6, and we have to find ratio of 18th term, a plus 18 minus 1, or we can say 17d upon capital A plus 17d. Let's try to find ratio of summation of n terms using its formula, which is n by 2 into 2 times a plus n minus 1 d. Similarly, n by 2, 2 times capital A plus n minus 1 capital D. Here, n by 2 will cancel out, and to form our required term, the coefficient of A is 1. So we have to remove this 2 by dividing numerator as well as denominator by 2. So we'll get A plus n minus 1 by 2 d upon capital A plus n minus 1 by 2 capital D, and it is given that Sn upon Sn dash is equal to 5n plus 4 upon 9n plus 6. Now, in coefficient of D, we have 17. So let's compare n minus 1 by 2 with 17, and you will obtain n is equal to 35. So in above equation, let's substitute n is equal to 35. You will get a plus 35 minus 1 by 2 into d upon capital A plus 35 minus 1 by 2 to d is equal to 5 times 35 plus 4 upon 9 times 35 plus 6, or we can say on left hand side we will get a plus 17d upon capital A plus 17 capital D, which is your required ratio of 18th term is equal to 179 upon 321. So, ta-da! In this question, we have sum of m and n term is n square by n square. So, in this question, we have only one AP having first term is equal to a and common difference is equal to d. Sm upon Sn is equal to m square by n square, and we have to show that the ratio of mth term upon nth term is equal to 2m minus 1 upon 2n minus 1. So let's try to simplify our given data using the formula of sum of n terms. So in numerator we'll get m by 2 into 2 times a plus m minus 1 into d is equal to m square, and in denominator we'll get n by 2 into 2 times a plus n minus 1 into d upon n square. So here 2 will cancel out, m will cancel out, and n will cancel out, and we will get simplified form. Now for further simplification, you have to cross multiply. You have to multiply n with numerator of left hand side. We'll get 2an plus m into n minus n into d is equal to, let's move this term with m. We'll get 2am plus nm minus m into d. So if we collect terms of 2a on the left hand side, we will get 2a into n minus m, and collect the terms of t on the right hand side, we will get nm minus m minus m into n plus n. So your n will cancel out and we'll get d into n minus m, and your left hand side will be as it is. So we will get 2a is equal to d. Let's say this is your equation number 1. Now let's begin from the left hand side, which is ratio of m terms upon n terms is equal to a plus m minus 1 into d upon a plus n minus 1 into d. But according to equation number 1, we can substitute 2a instead of d. So we can take a common from the numerator as well as denominator. So we'll get 1 plus 2m minus 2 and 1 plus 2n minus 2, or we can say 2m minus 1 upon 2n minus 1, which is equal to tm upon tn. Hence proved. Ta-da! In this question, it is given that sum of first P, Q and R terms in AP are ABC respectively, and we have to prove this thing. So first of all, we have to assume that the first term of the AP is capital A and the common difference is capital D. Now, let's use the formula of sum of n terms, and it is given that the sum of first P terms is given as A. So we can say we have to replace n by p and we will get p by 2 into 2 times a into p minus 1 d is equal to a. For simplification, we can move these 2 on the numerator and p on the denominator on the right hand side. So we'll get equation number 1. Similarly, sum of q terms is equal to d. So we can say replace n by q. We'll get q by 2 into 2 times a plus q minus 1 into d is equal to b. For simplification, 2 go in numerator and q will move to the denominator of the right hand side. So we'll get second equation. Similarly, sum of r terms is equal to c. So we'll get 2a plus r minus 1 into d is equal to 2c by r will become third equation. Now, to prove our term, we have to obtain q minus r, which are in second and third equation. So let's take difference between second and third equation. So your 2a will be cancelled out, and from second term we can take d common and you will get q minus r on the right hand side is equal to, we will get 2b by q minus 2c by r, and to make q minus r subjective, your d will be moved to the denominator of the right hand side. Similarly, to obtain r minus p, which are in third and first equation, we have to take difference between third and first equation. So let's get your third and first equation and take a difference between them. So your 2a will be cancelled out. From second term, we can take d common and we'll get r minus p is equal to 2c by r minus 2a by p. And you know that to make r minus p subjective, we'll move d on the denominator of the right hand side and we'll get fifth equation. Similarly, to obtain p minus q, which are in first and second equation, we can take difference of them and can obtain p minus q is equal to 1 upon d into 2a by p minus 2b by q. So we are ready for our left hand side. So in first term, a by p will be as it is and we get the value of q minus r. Similarly, b by q will be as it is and we already obtained the value of r minus p. And in third equation, c by r will be as it is and we have the value of p minus q. So as you can observe, we can take 2 by d common. So from first bracket, we get AB by PQ minus AC by PR, plus from second term, we'll get BC by QR minus BA by QB, plus AC by PR minus BC by QR. So as you can see, your all terms will be cancelled out and you will get 0, or we can say your required right hand side. So we get our left hand side is equal to your right hand side. Hence proved. Ta-da! In this question, it is given that summation of n terms of AP is 3n square plus 5n and mth term is 165. You have to find the value of m. So it is given that summation of n terms is equal to 3 times n square plus 5 times n. And we know that to obtain any AP, we need first term and the common difference. So let's obtain your first term by taking n is equal to 1. You will get summation of one term, or we can say it is your first term is equal to 3 times 1 square plus 5 times 1 will give us first term is equal to 8, and to get common difference we need second term. So we will get S2, or we can say summation of first and second term will give us 3 times 2 square plus 5 times 2 will give us A plus A2 is equal to 22. But we know the value of A, which is 8. So we can obtain your second term by moving 8 on the right hand side. So it will become minus 8, and we will get second term is equal to 14. So here we are ready for the common difference, which is second term minus first term, where your second term is 14 and first term is 8. So we will get common difference is equal to 6. Now it is given that your nth term is equal to 164. So let's use the formula of Tn. Will give us A plus m minus 1 into D is equal to 164, where the value of A is 8 and we have to find the value of m by substituting your D, which is 6. Now let's make m minus 1 subjective by moving 8 on the right hand side. We'll get 164 minus 8, and this 6 will move in the denominator. So we will get m is equal to 26 plus 1, or we can say 27, which is your required answer. Ta-da! In this question, we have to insert 5 numbers between 8 and 26 such that resultant sequence is in AP. That means we have to find 5 arithmetical means between 8 and 26. So first of all, we have to find common difference between them, which should be b minus a upon n plus 1, where b is 26, then a is 8, and your n is 5. So we will get common difference is equal to 18 by 6, or we can say 3. Now your nth arithmetical mean is given by a plus nd. So we can say for n is equal to 1, we will get a1 is equal to a plus 1d, which is 3. So we'll get 11. Then for n equal to 2, we will get a2, which is equal to 8 plus 2 times d, will give us 14. Similarly, your third mean will be 17, then fourth will be 20, and fifth will be 23. So we get our required numbers, and your arithmetical progression will be 8, 11, 14, 17, 20, 23, and 26. Ta-da! In this question, we have to insert m numbers between 1 and 31 such a way that resultant sequence is in AP. That means we have to find m arithmetical means between 1 and 31. So we can say common difference, which is b minus a upon n plus 1, will be 31 minus 1 upon m plus 1, or we can say 30 upon m plus 1. And it is also given that ratio of 7th and m minus 1 term is given by 5 by 9. So let's use the formula of an. A plus 7d upon a plus m minus 2d is equal to 5 by 9, where your a is 1 and d is 30 upon m plus 1. Similarly, we can form denominator will be 5 by 9. Now, in numerator, take LCM of m plus 1. So it will multiply with 1, will give us m plus 1, and 7 into 30 will be 210 upon m plus 1. Similarly, in denominator, m plus 1 multiply with 1 will give us m plus 1, and 30 multiply with m minus 2 will give us 30m minus 60 whole divided by m plus 1 is equal to 5 by 6. So here your m plus 1 will cancel out. We will get m plus 211, and denominator m plus 30m will be 31m, and 1 minus 60 will be minus 59 is equal to 5 by 9. Now let's cross multiply. 9 multiply with m plus 211 will give us 9m plus 1899 is equal to 155m minus 144. So here we'll get 146m is equal to 2044, or we can say your m must be 14. Here's your final answer. Ta-da! Here we have one problem sum. A man starts repaying a loan as a first installment of 100 rupees. Then, if he increases the installment by 5 rupees every month, then the next installment will be 105, 110, and so on. So it is clear that your sequence is in AP, where its first term is 100 and common difference between second term and first term is given by 5, and we have to find what amount he will pay at 30th installment. That means we have to find T30, for which we can use formula of nth term, a plus 30 minus 1 into d, where your first term is a plus 30 minus 1 will be 29, and common difference will be 5. So we will get 245 as your 30th term. Thus, the amount of 13th installment will be 245 rupees. Ta-da! In this problem sum, we have difference between any two consecutive interior angle of polygon as 5 degree. That means your common difference must be 5 and the smallest angle is 120 degree. So we will consider that as your first term and we have to find number of side of polygon. Now here we are going to use the fact that the sum of interior angle of polygon of n side is given by n minus 2 into 180 degree. That means we have to find Sn using its first formula where your summation is given by n minus 2 into 180. Now let's move this 2 on the right hand side. We'll get 180 into 2 is equal to n into 2 times a, which is 120, plus n minus 1 into d, which is 5 degree. So let's simplify. 360 into n will be 360n and 360 into 2 will give us minus 172, and on right hand side n multiply with 240 will give us 240n, then 5n square minus 5n. Now let's form polynomial. We'll get 5n square minus 125n plus 72 is equal to 0, or we can take 5 common and we'll get n square minus 25n plus 144 is equal to 0. So we can factorize our polynomial into n minus 9 and n minus 16, which will give us n equal to 9 and n equal to 16. Before we declare this as your final answer, we have to check them one by one. For n equal to 16, your largest angle will be a plus 16 minus 1 into d, or we can say 120 plus 15 into 5 will give us 195, which is greater than 180 degree. So we can say your T16 is not an interior angle. So this answer is not acceptable. Now let's check n equal to 9. Then your largest interior angle is 120 plus 9 minus 1, or we can say 8 into 5 will give us 160, which is less than 180 degree. So we can say n is equal to 9 is a final answer. Hence, the number of side of polygon is 9. Tada!